So try this problem first, and then I'll explain it. Okay, so the first thing is just to analyze what this is. So Na plus is just Na plus 1, right? So it doesn't really matter. And the main thing is CH3S minus. So this is a strong nucleophile and a weak base. Now let's see what kind of reactions we can do. Well, if it's a strong nucleophile reactions are SN2. And SN2 prefers primary and secondary. An exception to the rule is if it's next to a quaternary, it will not work, right? So, I mean, it's really slow, but pretty much no reaction will happen. On a test, it wouldn't work if it was next to a quaternary. So if we look at it, right, this is actually next to a quaternary, right? Because this carbon right here, next to the leaving group, is a quaternary because it's attached to 4 carbons. So SN2 actually will not work. So we're actually going to go with E1. So E1 prefers tertiary and secondary, and that's okay because this one is a secondary. So for E1, the leaving group leaves, right? So Br leaves, and then a plus charge will form. Whenever you form a carbocation, always make sure to see if a methyl or hydride shift can happen to stabilize it, and it can in this case, right? It can move there, which will form a tertiary carbon instead, right? So a methyl comes over here, it forms a tertiary carbon, and notice how the stereochemistry goes away, because after the carbocation moves, this can be a wedge or a dash, so the stereochemistry moves away. And then finally, for E1, a double bond forms, so wherever there's the carbocation, a hydrogen would be taken away right here, and then the double bond would form right there. So I hope that helped, and thanks for watching.